Hello. Hi. Uh, we have a new objective for today. It's a little one. The objective for today is to create an electrical circuit and use ammeter and voltmeter to measure electric current and voltage in that circuit. We're going to do that by using a lab, which is a virtual lab online. And it is very important for you to learn how to use this lab because we're going to use the same lab to come up with several different laws which we're going to study throughout the course of this current unit that we're covering. So what you need to do first is you need to go to this website, phet.colorado.edu. This is University of Colorado in USA. So they have developed these simulations. So you go to simulations and you go to physics. Now, once the sims are opened, there are quite a few of those, you are going to hunt for this one. It says Circuit Construction Kit DC. DC standing for direct current. That's what we're doing. So when we click on this one, it's going to bring us to a page with some, I don't know, what's this? Okay, it's telling us something about the app. We just go to the play button and the app starts. And it has two modes that you can use this app. One of them is the lab and the other one is intro. For now we're going to use the intro because we want to learn how to use the lab. So this blue thing here, this is like a table where you're going to assemble your circuit. And this electrical circuit that you're going to use has several elements. Those important elements are the source of electricity. In this case, this is battery. So we're going to take the battery out. Then we need some kind of an appliance that is going to use that electricity. In our case, that's going to be the light bulb. And you also must somehow deliver this electricity to the light bulb. And in order to do that, we use wire. And of course, we want to control this because we don't want the light bulb to be on non-stop. We want to control to turn it on and off. And for that, we use this switch thing. So I will go through these elements to explain some important things about them. When you click, so these are the basic elements of an electric circuit. So when you click on each of these elements here, you have some kind of a control. For example, when I click on the battery, I can control the voltage of the battery. Current, I can reduce it, I can increase it. Currently it's 9 volts. I will move the battery a bit upwards so you can see. I can also turn the battery on the other side, so switch its polarity by using this key. And I can also delete it if I click on this button. Here the battery is going to go away. Alright, but I need it. Then for the light bulb. For the light bulb, I can change only its resistance. Currently it's 10 ohms. I can make it more or less, and I can delete it. For the switch has two sections, open and closed. So in this case it's closed, which means that electricity can pass through it. And when the switch is open, then the electricity cannot pass through it. So the electrons cannot move through it. The electric current cannot pass. All right. Now, each of these elements has these tiny like circles around it, which are with kind of a red dashed lines. So the ones here and the ones here. Those are all the points that you should try to attach the elements to. So for example, this section of wire, if I drag and drop just the red circle, I can actually extend its length and I can change its direction. And I want to attach it, let's say, here at the light bulb. Now, the important thing about the light bulb is it has these two circular paths. Okay, so when you make this bond, you can also break it by clicking on it and clicking the scissors icon over there. It is very important when you are connecting a light bulb, both of these circular sections have to be connected. So for example, I have two pieces of wire now. I must connect one piece of wire to the one entry, which is the input for the light bulb. And then for the other wire, I will connect it into the other open section. The reason why I have to do this is to allow the electrons possibility to flow through the light bulb. So the electrons from this wire will move. Here they're going to enter the light bulb, move through it, and here they're going to go outside of the light bulb. If I don't do that, if I, for example, connect them like this at the same point, then I have made it a short circuit. Now the electrons are going to move through the wire, they're not going to go into the light bulb. So make sure you don't make that tiny mistake. Now, to make an electric circuit, you have to connect all of these elements, but you have to connect them in such a way that it always makes the closed loop for the electrons to move. So let me make one simple circuit. So I already have the light bulb here installed. I already have these two wires. Now, one important way of important thing that you need to know about wires is when you are actually trying to connect the circuit, you should aim to put the wires horizontally in vertical direction, and you should aim to have right angles between the wires. So on the corners there should be right angles. The reason why we do this is when you're putting all the cables in the walls in your house, you're putting them in that way. They either go vertically or horizontally, and they always are meeting corners at 90 degrees. This is important so you can actually easily trace where the wires are in the walls. Otherwise, it will be very difficult to know where a wire is, and then some unwanted accidents can occur. For example, you would like to put a painting on your wall, and when you're putting a nail in the wall, you hit the cable and then you get electrocuted. Right? So that's why it's important to actually uh, follow this important rule of how the wires should be set up. So if this rule applies, then if I take another section of wire here on the other side, I will have to put it downward in nearly 90 degrees. Then I'm aiming towards the battery. I connect this one to the battery here. So half of my circuit is done. Now this switch, I can rotate it a little bit. Here it goes. I take a section of wire to connect it to. Then from the bottom side, I aim towards the battery. And then I connect it here with the battery. So now my loop is here, my circuit is here, but the light bulb does not give out any light. The reason for that is because the switch here is actually open, so we want to close that switch. Once we close the switch, we can see that the light bulb actually gives off light. And the very handy and very important thing about this lab is that actually you can see the electrons. So these little tiny circles, the blue ones that have minuses on them, those are all electrons, how they are moving through the wire and through the light bulb and back into the battery. And important thing is, you see they also move through the battery. That's actually very important. So when you have battery in a circuit, the electric current also moves through the battery. All right, now to measure what is the voltage and the electric current here, we have these two items over here, voltmeter, which is going to measure the voltage, and the ammeter, which is going to measure the electric current. For this section here, show current when it says electrons, that's what we want. So conventional, forget about it. We're not going to talk about that still. We're interested in the motion of electrons, so that's why we want this electrons option here to be selected. So to measure the current, I need to take this gauge here and just put it in whatever place here on the circuit in order to measure how much the strength of the electric current is. So if I put it here, it says 0.9 amps. If I place it here, the current there is 0.9 amps. If I place it here, 0.9 amps. Place it here, 0.9 amps. So actually in this circuit that I have here, the current everywhere is 0.9 amps, which makes sense because it's only one current that flows in here, and that current cannot change, right? So that's 0.9 amps. Now, in order to measure voltage, well, if I connect it, you always have to connect on the opposite sides of the battery. So if I put these two electrodes, it tells me that the voltage on the battery is 9 volts. And if I click the battery, it also says it's 9 volts. So that's correct. So that's a good assumption. Now I can measure the voltage on the opposite sides of the light bulb. If I place it there, it's 9 volts. So the voltage of the battery somehow transferred through these wires. But if I measure on one side, so let's say only on the right side of the light bulb, I get 0 volts. Right? So think about it. This is a little bit difficult concept to understand. When I have both of these electrodes only on the one side of the electric current, oh sorry, of the light bulb, actually I am measuring, so you see this wire connects only one pole of the battery. Right? And that pole, well, there's no potential difference. Remember when we talked about voltage, we said voltage, we also call it potential difference. So we want to actually measure the difference between the two poles, the difference on both sides of the battery, right? But in this case, we're measuring only on one side of the battery, no difference over there. So that's why 0 volts. If I try on the other side, it's also 0 volts. But if I move on the opposite sides of the bulb or the opposite sides of the battery, it immediately gives me 9 volts. Alright, to check if this is correct, I can increase the voltage of the battery. That increases the reading on the voltmeter, which is good. Increases the current in the electric circuit. That's something we'll investigate. And the cool thing, it also increased the light emitted by the light bulb. Alright, so your job for today is to actually follow all of these my steps to make a circuit like this on your own computer, and to notify me if you can create it or not. So you just need to give me a hint. Just write it either as a comment on Google Classroom or send me an email. Yes, I can do it, because it is important for me to know that each and every one of you has a computer on which this app can run. So after that, we can make our investigations all together on the computers. If you have any questions, feel free to write me an email or schedule a Google Meet so we can talk about it, or through Google Meet we can work in parallel so you can create your own, you can get help to create your own circuit. That would be it. Thank you very much for today. You'll hear me again from me Friday. Bye bye.